Okay, so today what we want to talk about, 3, 6, 18, is we're going to find polynomial functions from a scatter plot. Okay? Okay, before we do this, I'm going to have you turn this paper over. Turn it over. Everybody turn it over. And let's look at the 3 that we're going to look at. We already know what a linear straight line, right? I'm going to look at 3 others. Okay, one is the quadratic, which I think you know what a quadratic looks like. A quadratic model. And we know that's some y equals some ax squared plus bx plus c, right? Where a, b, and c represent numbers, right? A, b, and c represent numbers. And if we were to take a look at a scatter plot of a quadratic model, I'm just making stuff up. It might look something like, let me get the right color pen. Here we go. Here's blue. Had a good color. Had a good color. There we go. So if I had a graph that maybe did this kind of thing here, as a scatter plot, I mean, that sure looks like we could fit a parabola to it. You guys agree? So today if we do a scatter plot, we do dot to dot dot, we look at it and go, hey, that looks kind of like a parabola, then it would be a quadratic model, right? You guys see that? Okay, now the other one is if we had a cubic. Okay, a cubic model. And the cubic model is going to be some y equals some ax cubed, cubic, right? X cubed. Oh, plus some bx squared plus cx plus d, where a, b, c, and d are just numbers, and the calculator is going to give us the numbers, okay? All right? So a, b, and c are just numbers, and the calculator will give us the numbers to put in, okay? Now, a cubic model might look something like this, okay? So if I did a scatter plot, a cubic model might look something like this. If we did a scatter plot, right? That looks like it might be a cubic model, right? We might be able to draw a cubic in there, right? Just like we're able to draw a parabola in there, right? Okay, so today we're going to be given certain problems. We're going to do a scatter plot, and we're going to say, well, which one is it, right? We're going to take a look at it. Which one is it, okay? But that's kind of the shape of a cubic, right? Okay, the fourth one we're going to do is the quartic. It's called quartic. Quartic model. And the quartic model would be some y equals some ax to the fourth. Quartic means fourth power, okay? Plus some bx cubed plus cx squared plus dx plus e. And I'm just using the letters. All these letters just represent numbers, okay? That's all they are. You know, it might be 5 and 6 and maybe -2. Maybe it's 1.3. Who knows? These are the numbers that the calculator is going to give us, right? So A, B, C, and D and E are just numbers that are going to show up on our calculator, okay? Now, a quartic could look like this, okay? So I did a scatter plot, and maybe my scatter plot looks something like this. Just give you an example. Okay, this is kind of what a quartic might look like. Okay, and there's a scatter plot. And if I were to try and draw a line through all my points, it might look something like that. Okay, that would be kind of a quartic, okay? So we've got our 3 graphs. And today we're going to do different scatter plots. And we're going to ask ourselves, which one is it? Because we need to know which one it is, and then the calculator is going to help us. So sometimes, though, you take a look at these. Sometimes they'll look a lot of the same. So sometimes maybe we'll only see this part of the graph. Are you watching? And maybe this part of the graph. So the two equations could almost be the same, couldn't they? if that's all you see of it, right? And the same thing with this. So the three could look almost identical, so it's hard to tell. But the calculator has a way of telling us which one's better. So to get it, before we even start any of this, we're going to try and find this thing called the R factor. It's going to be our test, but before we do anything, we need to turn our test on. So we're going to go to turn our test on our calculator. We're going to go to our catalog. And our catalog's in blue. All right, catalog's way down here in blue by the 0. You guys see the catalog? So I'm going to go second catalog. I'm going to turn it on, clear, second catalog. Okay, and I got a bunch of stuff in my catalog. I got a bunch of stuff in catalog. I don't want all of this. What I'm looking for is diagnosis. So, but I want to go to the diagnosis on. I want to turn my diagnostic features on. So if I'm going too fast, let me know. But I went to catalog. Everybody at catalog? So I found catalog. It's down by the 0 in blue. Everybody there in catalog? So let's scroll down until we find the word diagnosis. Okay. It's in alphabetical order, right? C, D, okay, getting there. There it is. So I've got two diagnoses. One is diagnosis off, and the other's on. We want it to be on so that we can get some information. Okay, so we're going to push enter, diagnosis on, boom. We have to do this because we will not be able to get the R's without having the diagnosis turned on. Now the diagnosis is turned on so that when we do our calculator calculations, our calculator will then do a diagnosis. Our calculator now will do a diagnosis on our data. It's going to tell us how good it is, okay? Now, this R squared has to do with what percentage of the points line up. The closer we are to 100%, the better, right? Makes sense? If I get an answer of 1, that means every single point would be on the line. That's good. 100% is good, right? If we get like 0.9, that means 90% of our line. So let's go ahead and do this. So let's go ahead and first tackle this first problem. All right, example 2. So the table shows populations in the city from 1950 to 2000, okay? And we want to go ahead and first make a scatter plot. What I've done to help us out is I've kind of got our scales. I've got 1950, 1960, I think I'll add 1970, 1980, 1990, and 2000, okay? And thousands, there's 1,000, 1, 2, 3, 4, maybe go 5,000. 1, 2, 3, 4, 5, there's 10,000, right? 1, 2, 3, 4, 5, and there's 15,000. Okay, so I'm just going to put my scales on my graph, and then I'm just going to do a scatter plot, dot to dot, right? So I'm going to do a dot to dot, and we're going to let year 1950 be our first year, or year 0. The reason we let it be year 0 is because we don't know anything about 1940, right? For all we know, there was nobody there, right? And all of a sudden everybody moved there, okay? Or maybe aliens came in and just inhabited the place, right? I don't know. So we don't know anything about 1940. So 1950 is the first year we know anything. So that's why we call it year 0, okay? So let's do a scatter plot. Okay, year 0, 1950. I'm going to put a dot at about 2000, awfully close to 2000, 1950, so is about 2,800, so 1,000, 2,800. That's about there. Now we don't have to be perfect. We're just going to guesstimate. We want to get the general shape of it, okay? 1960 is about a 4,000, which is about there. 4,011. 1970 is about a 5,000. It's about there. 1930 is about a 16. 1980 is about a 6,000. There's 5,000, 6,000, 6,700. Maybe about there. 1990 is about 9,000. So it takes a jump, doesn't it? Okay, all of a sudden now it's starting to look a little bit more like it might be curving, right, with that jump. And then 2,000 jumps all the way to 14,000, which is about almost 15,000, isn't it? So at first it looked kind of like it was going to be a straight line, and then all of a sudden it got a little curvature to it, didn't it? Okay. So if I were to try and fit a curve, it might look something like Maybe something like that, okay? All right. Now which one is it? Is it quadratic? Is it cubic? Is it quartic? I don't know. But I'm going to let the calculator tell me which one's the best fit, okay? So how do we do that? So let's do what we did before. Remember how we went into stat? We went to edit, right? We entered our data. Remember how we did that? We went to stat, we entered our data, enter data, right? Then we went to calculate, and we go to calculate. That's when we want to push each of these to find out which one's the best. So let's do that. Okay, you guys ready? And we've done this part before. Okay, so when I go into stat, right? Hit stat. All right. I'm going to go to edit because I need to put some numbers in. Okay. Luckily, I did this first period, right, or second period, so my numbers are already in. Okay. So you put in list 1. I put 0 because that's year 0. So I went 0, 10, 20, 30, 40, 50, right? And then I put into the list 2, I put the populations in, right? And if you need to clear your data, remember how you clear your data? You highlight your list, push clear, then push down. Anybody need any help right now? Anybody need help at all? You guys are good? Of course, we've done this before, right? Right? Okay, so you put all your data in, right? Okay, give me thumbs up when you're ready. I'm watching. You guys are still putting stuff in, right? Okay, put your data in, right? Now mine are in list 1, list 2, right? So, what we'll do next, when you're ready, is we need to calculate an answer, okay? We need to come up with an answer, so we're going to calculate an answer. So I'm going to go back to, am I going too fast? Stat. Okay, I'm at stat. I push stat again. And this time I want to go over to calculate, right? Well, we need to try all 3. We need to try all 3, okay? So the first thing I'm going to do is go to my quadratic regression, right? We're going to try all 3. I'm going to go to quadratic regression, and I'll push enter. Am I going too fast? Quadrig, enter. Now I got to go list 1, L1, comma, L2, right? L1, L2, and I'll push enter. Now first of all, what I'm more concerned with right now is the R2. That tells me, that's my correlation coefficient. That tells me how good my data is. So I got 99%. I got 0.99. That's pretty good, isn't it? That's pretty good. 0.99025. Okay, so this one's got about a 0.99025. Okay, that's pretty darn good. The closer it is to 1, the better the fit. Okay, let's see if the cubic's any better. Probably not, but let's see if the cubic's any better. So then, to find out what the cubic one is, I'll do it again. I'm going to do this whole thing again. I'll go to stat, calculate, but this time I'm going to test my cubic regression. All right. Okay. Enter. You already got it. L1, comma, L2. Let's see which one's better, okay? Oh, that one's really good. You guys agree? That one's a 0.999999. That's almost 1, right? So about a 0.9999. How many nines? 1, 2, 3, 4, 5, 6, 6 nines. 1, 2, 3, 4. Wow. And then a 494, right? And then we can try the quartic, but my guess is the cubic is what it is. You guys kind of agree with that? If I try the quartic, do it again, stat, calculate. This time I'll try the quartic, L1, comma, L2. Wow, look at that. The quartic's even better. The quartic's even better, isn't it? So which one are we going to choose? We're going to choose the quartic, aren't we? Because the quartic is like 0.99999, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's much better. So we're going to pick quartic. You guys agree? Let's pick quartic. And so the answer to the quartic then, let's check it out, is, there it is. There's our our A. Here's our A, B. Let's see if I get this light better. Can you guys see that out of the glare? Now, there's something important to see about A. If I can get the glare out of there. There's the A. Now, check it out. A is not 0.707. It is not. See this E? -5? It is, move the decimal, 1, 2, 3, 4, 5. A is actually 0.000077 because of the E. Does that make sense? Scientific notation. Move the decimal back 5 places. 1, 2, 3, 4, 5 because of this E. -5. Okay, that's scientific notation. I know my B is going to be 0.113. My C is -3.97. My D is 144.16. And my E is 2,850. I'll just round up to 53, okay? Now, that's not my equation, is it? That's just A, B, C's, and D's. That's not my equation. My equation's got to have X's in it, right? Because it's a function. So I'm going to rewrite it as, well, here's my equation. Y equals, you ready? 0.0000077x cubed. Because we, fourth. My bad, fourth. Because we picked quartic, didn't we? Jerome.
I think you have one too many zeros in the first one.
1, 2, 3, 4, 5. No, I'm okay. On this one? 1, 2, 3, 4, 5. Yeah. Thanks, Jerome. You're right. Good thing I have a jar of whiteout. Good thing I have 2 things of whiteout, huh? Yeah. Thanks, Jerome.
Yeah.
Good eye. Good eye, Jerome. Go ahead and take that. That's out of here. Thanks, man. Good eye. And then, let's see, we're also going to have then a plus 0.113x cubed, right? Minus a 3.97x squared plus 144.16x plus 2,853. Okay, I'm going to highlight that because that's my answer, okay? I'll highlight that. Right. So that's my equation, right? That's my equation. Whew, that's a big equation, right? So now, let's do the second piece. We're almost done. Can we use our equation to predict 2050? Sure. Let's plug in 2050 in for x. No.
On 100.
Yes. Don't plug in 2050 because 1950 was year 0, wasn't it? If 1950 was year 0, then 2050 would be year 100. Do you agree with that? Because we never used 1950, we used 0, right? We never used 1960, we used 10 in our calc, right? So we're just going to plug 100 in. Now that's a pretty big equation, but I'm going to plug it in. So we're going to go, right? 0.00077 times 100 to the 4th plus 0.113 times 100 cubed minus 3.97 times 100 squared plus 144.16 times 100 plus 2,853. Now I'm going to definitely use my calculator. Guys agree? Definitely. Oh my goodness gracious. Yeah. Clear. Slide that up. My calculator. Okay. So I'm going to go 0.12347 times 100 to the 4th power plus 0.113 times 100 to the 3rd power minus 3.97 times 100 squared. How am I doing? Plus 144.16 times 100 plus 2,853. Boom. About 98,000. Wow, that's weird that came out even.
Yeah.
Wow. What are the odds of that with all those decimals? Okay, so my population in 2050 is about 98,269.
Well, Mr.
People.
Davies, if you. I did the 2,894.96, and then it doesn't come out even.
Then you truncate the last person, right? Because you can't have a
Yeah.
decimal person. Yeah, nice job, Jerome. Okay, you probably had a little bit more accuracy than I did. Okay, there you go. Not too bad. So today we've got lots of time, but the main thing is you're going to need the calculator. You guys agree? You're going to need the calculator. So